My name is Jean-Philippe Brantut. I'm a physicist. I have a fascination for complex machines, especially those which give you access to things that you normally do not encounter in everyday life, like microscopes or telescopes. And the place where we are facing phenomena that defy intuition is quantum physics. So I dedicated my career to build machines that show, explore, and even control quantum physics. My field of research is quantum guesses. Those are guesses that are extreme in many respects. They are extremely thin and dilute, about 10 billion times thinner than air in this room, and extremely cold, about 1/1,000,000 of degrees above absolute zero. They can also be put in extreme interaction conditions, where the atoms that constitute the gas collide with each other as strongly as permitted by the laws of physics. And there, the properties of matter are fully ruled by quantum mechanics. But this was not extreme enough, so in my lab at EPFL, we have also increased the way by which they interact with light, to the point that a single photon is enough to change the properties of atoms significantly. My group has built these unique machines that allow us to control all these properties and bring them to these extremes. What I find most exciting is that when we create these extreme systems, we can really get some surprises. For example, when we first managed to raise the interaction between atoms and light, we discovered that light was not only interacting individually with each atom, but also that pairs of atoms would also interact strongly with a single photon, which was really unexpected. Our capacity to push these gases further into the extreme keep expanding as we improve and expand our machines. For example, we now know how to turn our control over light-matter interaction into a tool that makes the atom correlate their motion and states with each other, forming new types of matter with new properties. I do not know how further we can push and how extreme we can make our systems. Every time we push the boundary one step, we open the door to new types of phenomena. And then there's always a colleague or a student to drive us towards another step. In the end, I like the idea that my activity probably looks like old-style craftsmanship, designing and building ever better machines, and my lab is as much a research laboratory as a workshop.